I often talk about one rock run as a great way to conserve energy, especially on long runs. But I've been thinking lately about how much energy does it save, and does run-walk ratio matter, or are there better ratios than others? So I did some experiments, and some of the results I got were exactly as I expected it, but some weren't. Hi, I'm Ralph, and welcome to the Ageless Runner. I enjoy running and sharing what I learn about running. And if you feel the same way, if you enjoy running and learning new things, then please consider subscribing to my channel. Thank you so much. Now, my Garmin Forerunner 245 will tell me the number of calories I burn when I do a run. It's just simply a matter of tracking the run, and it'll give me calories. So I thought that would be a great way to run an experiment to look at, as I vary one rock ratio, how will my calories change? So I did an experiment where I looked at 5 ratios from 1 to 1 to 5 to 1. And then I did a reference run. By reference run, I mean I did no walking at all. It was just a flat out run. So it's really important when you do an experiment to control as many variables as you can, except the one you want to evaluate. And although we want to evaluate one rock ratio, I did that by changing my run time. I kept my walk time constant at 20 seconds. So all the run walk ratios were 20-second walk time. Other things I did, I tried to control my running speed at a slow pace, about 13 minutes per mile. And that's kind of a challenging thing to do, but I did the best I could. I also ran the same circuit. I ran a kilometer circuit around my neighborhood that would kind of make elevation gains and losses the same, and somewhat keep the wind the same, although there was some wind variation, but I can't control that. And I always ended my tracking on my Garmin watch after a walk break. In other words, I ended with a full run cycle followed by a walk cycle. And I also waited between runs until my heart rate got down below 60% of my max heart rate before I started another run. That way I had similar recovery. And of course, I did a warm-up. I did a warm-up run before I started the experiment. Now, one last thing I did for my experiment to try and be consistent is I wore my Garmin heart rate strap. I think Garmin uses heart rate in calculating calories, and using the strap will give me much more consistent results than just relying on my watch. So I tried to be as consistent as I can throughout the test, except varying run time. So I did all 6 runs, 5 ratios, and a reference run, and got the data. Now, the thing about the data is what we want to look at. We don't want to look at absolute values because my run times and distances varied a little bit. Because I wanted to always end on a walk break, I might have to run a little longer on sometimes than other runs. And really, we're not interested in absolute numbers. We're interested in a rate. How quickly do we burn through calories when we're doing different ratios? There's 2 ways you can look at it. The first way is, of course, is look at it calories per mile. But we're not going to do that, and that goes back to physics. If you took high score at college physics, you may remember that a definition of work, which is energy expended, is the product of a force over a distance. So the force in this case is me, my weight, going a kilometer. Now in physics, there's nothing in that equation about time. In other words, in an ideal world, the amount of calories I burn walking a mile and running a mile are the same. Now, it's really not an ideal world, so there are some slight differences. You know, I may be more efficient walking than running. Certainly my feet spend more time on the ground when I walk than I run, so there's friction differences. But I'll show you some information later in the video that the differences between calories per mile for all my runs was less than 4%. So the physics kind of holds. Now, what we're going to look at is calories burned per rate of time, and I'm going to look at 10-minute block. How many calories would I burn in 10 minutes at each of these ratios or my reference run? So essentially what I did is I took the amount of calories I burned in a run, divided by the time in minutes, and multiplied that by 10. And the best way, as I said, to look at this data is through a picture. So here's my picture. Now this is a graph where the horizontal axis is ratio. You can see 1 to 1's on the left and 5 to 1's on the right. So ratio increases as we go to the right. The vertical axis is calories burned per 10 minutes. And we don't really care what the absolute number is. We care about how all the numbers relate to each other. And there's 2 lines on this graph. The red line is my reference run. That's where I did no walking. And I drew it across all the ratios because we want to look at how it compares to the energy burned when we do run. And so that's the blue line. So blue line represents the average calories burned in 10 minutes for each of those ratios. And this graph was no surprise. I expected as I increase my ratio and I'm running more and walking less, the rate at which I burn calories increase. And that's what this graph says. I do think the 2 to 1 ratio number may be a little high. Again, it was kind of challenging sometimes to keep my running speed the same. So that might be a little high because of that reason, but it doesn't really matter. It doesn't change the message in this chart. And what's the message? Well, the message is ratio does matter at an easy pace as far as the rate at which you burn calories. But it gets up to a point where it doesn't. You know, up to 5 to 1 ratio, there's only a 3% difference. So this kind of says if you want to conserve your energy, burn at a slower pace, if you want to keep your ratio, say, no higher than 4-to-1. Now, next thing that occurred to my mind is, well, what if I run faster? Well, you know, some people, and occasionally I do, we run a 5K where we run faster. You know, how does that impact the way at which we burn energy? So a couple of days later, I did the whole test again. I did a faster pace. I tried to run at about 2 minutes per mile faster, and I'm going to call that a 5K pace. So here's my picture for my 5K pace. Now this picture looks a little different. Now you can see that except for the 1-to-1 ratio, the rate at which I burn calories at a 5K pace isn't a whole lot difference whether I do run, walk, run, or I don't. It's less than a 4% difference. Now, I had to go all the way down to 1-to-1 ratio before I saw kind of a noteworthy reduction in the rate at which I burn calories at 6%. So what this tells me is, if you're doing a fast pace run or a 5K, for example, it doesn't really matter which ratio you pick as far as energy usage, because you're going to burn your calories about the same rate whether you do run, walk, run or not. You can pick your ratio for other reasons, fatigue or what works best for you. Ratio doesn't really matter unless you get to very low ratio. You get 1-to-1 or lower. I am going to summarize all this information here towards the end, so bear with me a little longer. So let's jump back to my physics point earlier that all the calories per mile for every ratio ought to be the same in an ideal world. So here is the data. Here is the picture, only instead of the vertical line being calories per 10 minutes, it's calories per mile. Again, the red line is my reference run, and blue line is the amount of energy I burn per mile for each of the ratios. And you can see they're almost on top of each other. There's less than a 4% difference. So this kind of holds up with the physics theory that no matter what ratio I run, I'm going to, per mile, burn about the same number of calories whether I do a 1-to-1 ratio or 5-to-1 ratio or don't walk at all. Hey, if you're enjoying this video, it would really mean a lot to me if you would scroll down and hit that like icon. Thank you so much. So that was the easy pace, calories per mile. What does the 5K pace look at? And this is the graph, the picture that surprised me the most. Again, horizontal scale is ratio, vertical scale is calories per mile. Red line's a reference run, and the blue line is the calories expended per mile for each ratio. Now, there's two things I'll jump out at you here because it did to me. One is I burned more energy in every one walk ratio than I did in the reference run of not walking at all. This says that run, walk, run caused me to burn more calories per mile than not walking. It's not a lot. It's less than 4%, but it did a little bit. And the other thing that surprised me is as I go down in ratio, the amount of energy expended goes up a little bit. You can see I burn a little more energy at a 1-to-1 ratio than you do a 5-to-1. A 5-to-1 ratio, the calories per mile are almost the same as not taking a walk break at all. And I thought that was interesting, and I thought about this for quite a while, and I finally decided it kind of illustrates the inefficiency of taking a lot of walk breaks. In other words, the amount of energy I expend accelerating from a walking pace to a 5K pace is higher than, say, for example, going from a walking pace to an easy run pace like the previous graph. And every time I do that, I expend a little more energy. And the more often I do it, the more energy I expend. So doing a 1-to-1 ratio at a 5K pace will cause me to burn a few more calories per mile than doing a 5-to-1 ratio because more times I have to deaccelerate and accelerate to a higher pace. So again, it's an interesting thing. I don't think it's something that factors in highly in your selection run walk ratio. And with that in mind, let's kind of summarize what I think all this experimentation told me anyway. And one thing to keep in mind is that calories burn rate is not necessarily equate to fatigue. Fatigue is a little more, calories are part of it. You burn through your calories, you get tired. But fatigue also incorporates lactic acid buildup in your muscles, muscle fatigue, and calories are just certainly one portion of it. So I think it's something to keep in mind. But what I learned from this graph, again, if you're doing an easy run, you're doing a long run, ratio kind of matters if you want to conserve energy. You may want to err on having a lower ratio, maybe no higher than 4-to-1. However, if you're going to be doing a 5K, if you're going to be doing a hard run, ratio doesn't matter, but one might make the argument that a little higher ratio is a little more efficient than a lower ratio. But, don't worry about energy use in a 5K because no matter what ratio you use, you're going to be burning through your calories almost the same as if you were not walking at all. Pick your ratio for some other means. And of course, all the experimentation brings up other questions, like what if it was hot out? What if I walk 15 seconds versus 30 seconds? And we may explore this in a future video. But if you enjoyed this video, it would mean a lot to me if you scroll down and hit the like button. And if you're new here, I'd like to continue sharing my thoughts with you in different aspects of running. Please consider subscribing. And if you click that subscribe icon, please also hit the bell notification so you get notified whenever I post a new video. Thank you again so much for watching and happy running.